In this review, we're going to be going over distributing and factoring. So for distributing, going over distributing first, this is going to be a method which involves multiplying over addition or subtraction. And when we're multiplying polynomials, the exponents are going to combine into one base by adding the exponents together. So let's see an example here, multiply and simplify. So we have 3x times x minus 7. So we have our two factors, 3x and x minus 7 are our factors, things being multiplied. So what we're going to do is distribute over subtraction, multiply the 3x times x minus 7, and 3x times x is going to give us 3x squared. So 3x squared, and then minus 3x times 7 is going to give us 21x. And that's all we have to do for that one. There's no like terms to combine. So that was multiplying a monomial by a binomial. One term distributing into two terms. Now we're going to be distributing for the next one. X plus 6 times x minus 2. We're going to be distributing a binomial times a binomial. So two terms times two terms. And this is when you can think of it as foiling. Foiling is just distributing, multiplying two binomials together. Okay, so you're going to multiply the first one into both terms in the second one first. So let's do that. So it's going to be x times x minus 2. X times x is x squared. X times negative 2 is negative 2x. And next we're going to multiply the second term from the first one into both terms in the second one. So multiply 6 by x minus 2, and that's going to give us plus 6x minus 12. This time we have to combine like terms. Remember, like terms are factors, are terms with the same variable factors. So that's going to be negative 2x plus 6x. That's going to be x squared plus 4x minus 12. And that will be our final answer. And the next one, we are now multiplying a binomial times a trinomial. Two terms times three terms. Technically, this isn't called foiling, but it's the same exact concept. We're going to multiply the first term in the first factor into each term in the second factor. And I'm going to go a little faster here. We get 15x to the 6th minus 9x to the 5th plus 3x to the 4th. So remember, you're adding the exponents when you're multiplying common bases. And now we're going to multiply the second term in the first factor into each term in the second factor. And we get minus 10x cubed plus 6x squared minus 2x. And we look for like terms to combine here. So you go to the exponents, and there are no like exponents for the same variable factor, so we can't combine anything, so we're actually done. Okay, next one, we have x plus 4 squared. So for this one, you have to know that x plus 4 squared is x plus 4 times x plus 4. I recommend knowing the shortcut for this, but I'll mention that in a second. So for this one, this is just foiling, so I'm going to actually skip right to the answer here. You're just going to distribute just like we've been doing. And after combining like terms, you should get x squared plus 8x plus 16. The shortcut way, if you have a binomial squared, it's going to be the first term squared, and then the last term, the 16 in this case, is the second term squared. The middle term will always be both terms multiplied together times 2. So 2 times x times 4 is 8x. So that's the shortcut that typically people use. Let's do one more for this one. 3x times 4x to the 1/3 plus 2 times the square root of x. So this is a monomial into something with two terms. Technically, we wouldn't call this a binomial because binomial would be a term used for a two-termed polynomial. And polynomials can only have positive integer values for their exponents. 1/3 and the square root are not positive whole numbers, so that's actually not a binomial. Either way, we do it the same exact way. 3x times 4x to the 1/3 is going to be 12 x, and what we have to do is add the exponents. We know that the exponent on the x is a 1, so 1 plus 1/3 is going to give us 4/3. You have to get common denominators. Hopefully you can do that in your head. Next term we have 3x times 2 times the square root of x. That's going to be 6. You have to remember that the square root is an exponent of 1/2. So adding the exponents, 1 plus 1/2 gives us 3/2. And there we go. So that is distributing. Now we're going to be going in the other direction with factoring. And what that means is now we're going to be rewriting an expanded expression as a product of factors, as a product of things being multiplied together. Essentially the opposite of what we were just doing. So there's 4 main ways, I'm putting quotes up, main ways for factoring expressions, because there's several other ways to factor, but these are the most commonly used ones. First one is greatest common factor, which we denote as GCF. Second one is difference of squares. Third one is quadratic trinomial factoring. And the fourth one is grouping. So you're expected to know all of these and be an expert with these ones going into this class. Let's do some examples. And the first example is GCF, using the greatest common factor method. So the greatest common factor for this first one, x cubed minus 2x. We have 2 terms. We have x cubed and negative 2x. The GCF between them is just going to be 1x. When we factor that out, we have to remember that we're dividing it out front for what's left over. So when we're dividing it out with the variables, what we have to do is subtract the exponents. We're left with x squared minus 2. Okay, and it's always good to check. You can distribute that back through and make sure you got what you started with. Next one, we have 15x to the 5th plus 20x cubed minus 5x squared. And for this one, the GCF is going to be a 5 for the constants. And then it's always going, for the variable, it's always going to be the variable with the smallest exponent. The smallest exponent out of 5, 3, and 2 is 2. So the GCF is 5x squared. When you factor that out front, remember you're dividing everything by 5x squared. We're left with 3x cubed, subtracting the exponents, plus 4x minus 1. So that little minus 1 at the end, you can usually trip some people up because they might forget it. If you're dividing negative 5x squared by 5x squared, you are left with that negative 1, that minus 1 at the end. All right, next one. We have 3xy to the 4th minus 6x squared y cubed plus 12x to the 6th y squared. So we have 3 different factors here. We have a constant, an x, and a y. And the GCF of the constant looks like a 3. And now looking at the x's, the smallest x exponent is a 1. And now looking at the y's, the smallest y exponent is a 2. So that's our GCF. And we are factoring that out front. We're dividing every term by that GCF to see what's left. We are left with an x squared minus 2xy plus 4x to the 5th, and that is it. And it's also good, like I mentioned, you can check by distributing and making sure it equals what you started with. It's also good to make sure there's no GCF inside of your parentheses, what was left over. If there is a GCF inside of there still, then your original GCF was incorrect. Okay, and last one for this one, we have x squared times x minus 7 plus 3 times x minus 7. So we actually have 2 terms here. We have that big term and that big term. So the GCF here is a little bit different. The GCF is actually the binomial x minus 7. So this is actually your GCF. You can have a binomial as a GCF, and what we're left with is just the x squared plus 3 after we factor that out, and then we're actually done right there. So it looks a little different, but it's actually easier. So if you divide the first term by x minus 7 divided by itself is 1, they cancel, so you're left with x squared. And then same thing with the second one, if you divide 3 times x minus 7 by x minus 7's cancel, and you're just left with the plus 3. Okay, so that is GCF factoring. Let's go to difference of squares. Difference of squares factoring is when you have something squared minus something else squared. So a squared minus b squared, which the name tells you, difference means subtraction. So difference of squares, two things that are squared being subtracted. You can factor this as a plus b times a minus b. Okay, so that's just something that you should know right off the top of your head, difference of squares factoring method. So this first one, we have x squared minus 1. X squared minus 1, we have two things being subtracted, and both of them are something squared. The first one's obvious, right? The first term we know is going to be x, because that's what the square root of x squared is going to be. And we know it's going to be x plus something times x minus something. This right here, the 1, we should think of this as something squared. We know that 1 is the same as 1 squared. So that 1 that's being squared is our second term in this a plus b times a minus b. Okay, next one, we have x squared minus 25. Hopefully we're good with these and we can just kind of go through them pretty quickly. So x squared minus 25. 25 we know is 5 squared, so that's going to be x plus 5 times x minus 5. It doesn't matter what order you put it in because multiplication is commutative. And then for the next one, it's a little bit harder. 16x to the 4th minus 81. So you should recognize that this one's harder because we have a constant of 16 here, and this is to the 4th power, and it's not squared. We can rewrite that, though, that whole first term, we can rewrite as 4x squared, all squared, because 4 squared is 16, x squared squared is x to the 4th. So all we did is rewrite it. We can rewrite 81 as 9 squared. The only reason why I did that is just for a visual. Now you can see that this would be our a value, this would be our b value, something squared minus something squared. So that would be a plus b times a minus b, 4x plus 9, 4x squared plus 9 times 4x squared minus 9. This first factor is done, 4x squared plus 9, because there's addition. It's difference of squares, not summation of squares. So since it's addition, we can't factor that anymore. The second one, though, we can actually rewrite 4x squared minus 9. We can do that one more time using difference of squares factoring, because that is the same as 2x all squared minus 3 squared. And once again, you don't have to write that. That's just for a visual. So we can factor the second one as 2x plus 3 times 2x minus 3. So for this particular one, we had to do difference of squares twice. All right, next one, we have the quadratic trinomial method. So quadratic trinomial, it's going to be a polynomial with 3 terms, and the highest exponent is a 2. So that's what a quadratic trinomial means. So once you recognize that that is what we are doing, if it can be factored, then it's going to be able to be factored as x plus or minus something times x plus or minus something. That's just something that you have to have remembered here. And you need two numbers that multiply to the constant term that also add to the x coefficient. So that's going to be two numbers that multiply to 12 that also add to 8. So that's going to be 6 and 2. Positive 6, positive 2, and that's all you have to do, x plus 6 times x plus 2. And you can distribute that, you can FOIL it, and make sure that you get what you started with again. Okay, so they can get a little bit tricky with the positives and negatives. So x squared minus 4x minus 5, x plus or minus something times x plus or minus something. These technically don't have to factor. They can be prime, meaning they do not factor. So we need two numbers that multiply to negative 5 that add to negative 4. That's going to be negative 5 and positive 1. Negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. Next one, x squared minus 14x plus 49. Once again, x plus or minus something times x plus or minus something. We need two numbers that multiply to 49 that add to negative 14. That's going to be negative 7 and negative 7. Negative 7 times negative 7 is positive 49. Negative 7 plus negative 7 is negative 14. And anytime you have the same factors, we should write that with an exponent. Let's write that as x minus 7 squared. Same reason why you wouldn't write x times x as an answer. You would write that as x squared. And next one, x squared plus 2x minus 15. So if it can be factored, then it can be factored to x plus or minus something times x plus or minus something. Two numbers that multiply to negative 15 add to positive 2, positive 5, negative 3, x plus 5 times x minus 3. And the last one here is the tricky one. We have 2x squared minus 5x minus 3. You should recognize that this one has a coefficient on the x squared term that is not a 1. Anytime you have this, it's going to be a little bit more difficult. And there's a couple different ways to do this, but they all kind of are the same thing, but they're a little bit different in the way that you actually do it. The way that I recommend doing it is you're going to take this middle term and you're going to rewrite it. So this is whenever you have a coefficient other than a 1 on the x squared term. I'm going to rewrite it as plus something x plus something else x, and then minus that 3. So what I did is I split the middle term up into two different terms. We need to figure out what these two numbers have to be. So obviously those two numbers have to add to negative 5, right? Because that's what we're splitting up. They also have to multiply to the leading coefficient and the constant term. So they have to multiply to 2 times negative 3, which is negative 6. That's kind of the tricky part for this, is you have to just remember that step. It's always going to be they have to multiply to the leading coefficient and the constant term, which is negative 6. So two numbers that multiply to negative 6 that add to negative 5, that is going to be negative 6 and positive 1. So negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5, so we are good. It does not matter where you put them. You could have put the 1 first. You could have put the negative 6 second. It does not matter. And I'm going to rewrite this now. 2x squared minus 6x plus 1x minus 3. So we didn't really do anything yet, right? All we did is rewrite negative 5x as negative 6x plus x. What you do now is you do this by grouping. And grouping is the last factoring method that we're actually going to mention in a second, but now we're going to mention it here first. So using grouping, you group the first two together and you group the second two together. You do the GCFs separately. The first GCF of 2x squared minus 6x is 2x. When you factor that out, you're left with x minus 3. The second group does not have a GCF, so it's just x minus 3. And now you factor out the binomial x minus 3. Factoring that out as your GCF, you're left with 2x plus, there is a 1 out here, so 2x plus 1. Okay, so that is your final answer for this one. So it's obviously a little bit more complicated, but if you just remember those short little steps, then it's not too bad. And that actually brings us to grouping. And for the first one here, factoring using the grouping method, we have x cubed minus 3x squared plus 2x minus 6. So kind of a hint for grouping, which won't technically always be the case, but a little bit of a hint is that there's 4 terms, and we do exactly what we just did on the previous one. We're going to group these first 2 terms together and group the last 2 terms together, and then do the GCF of both of them separately. The first GCF is x squared, and then we're going to be left with x minus 3. The second GCF is 2, and then we're left with x minus 3. And what you always want is you want these two binomials to be the same, because that's the next big GCF that you're factoring out. If they're not the same, then something went wrong. Okay, so you factor out the x minus 3. You are left with x squared plus 2. And that is your final factored form. Next one, there's actually a little bit of an issue with the next one. We have x cubed plus x squared minus 5x minus 5. So it looks pretty similar, but we cannot do this and put the parentheses like that. That's because if there is a negative here, we can't throw parentheses around the next two terms, because technically that would mean we would have to distribute that negative. That would make this last term positive 5, which would be changing the original problem. So we didn't have that issue in the one above because it was plus. Distributing positive 1 doesn't change anything. So if that is a negative right here, what you have to do is rewrite it as plus a negative 5x minus 5, and then put the parentheses in. So all we did was just put plus and then put the parentheses after that. Okay, once you realize that issue, then everything is the same. Factor out the first GCF, x squared, you're left with x plus 1. The next GCF is negative 5. And then when you factor out a negative 5, you're left with x plus 1. Now you can see that your big GCF is the binomial of x plus 1. Factor that out, you're left with x squared minus 5. Okay, so that is grouping. Now let's take a look at the last couple problems. We're going to factor these expressions completely using a combination of the methods that we just went over. So the hint here is typically you should always try to find a GCF first. That's not always going to be the case, but that's usually the best route to take. So first problem, 4x to the fourth plus 12x cubed plus 8x squared. So taking a look at the GCF here is 4x squared. And let's look at what we have left over. We're going to have x squared plus 3x plus 2 left over. And now, since it says factor completely, make sure that you are done factoring before you finish up. We are not done factoring because we have a trinomial right here that can be factored. We can factor that as x plus 2 times x plus 1. Because we need two numbers that multiply to 2 that add to 3. That would be 2 and 1. So your final factored version is 4x squared times x plus 2 times x plus 1. Okay, next one we have negative 2x to the 8th plus 72x to the 6th. So we have two terms, and there's clearly a GCF here. So there's kind of a little hint, that's something that you should typically do. If the leading term is negative, and when I say leading term, I mean the term with the largest exponent, in this case the 8th, x to the 8th. If there's a negative on it, you should include the negative as part of your GCF. Okay, so we're going to be factoring out a negative 2x to the 6th as the GCF. And now let's divide that out and think about what's left over. What we have left over is a positive x squared minus 36. Okay, so positive x squared minus 36. The signs changed because we factored out the negative. And we can go one step further because the x squared minus 36 is difference of squares. It factors to x plus 6 times x minus 6. And then taking a look at it, it looks like that is good. Okay, last one, we have 2x to the fourth minus 2x cubed minus 18x squared plus 18x. It looks like there is a GCF here. There's a GCF of 2x, and we factor that out front. We are left with x cubed minus x squared minus 9x plus 9. And the expression or the factor in those parentheses there looks like that can be factored using grouping. So using grouping, when we group the first two, and group the second two. Remember, we have to be careful because there's that negative. So I'm just gonna skip ahead to, I recommend you try this on your own. I'm gonna skip ahead to the answer here. So when we do the grouping, we actually end up with x minus 1 times x squared minus 9. And then you might recognize, okay, x squared minus 9 is difference of squares. That can be factored again. So we had to do grouping here. And then from the grouping, we had to do difference of squares. So we get 2x times x minus 1. X squared minus 9 can be factored to x plus 3 times x minus 3. So we have these four different factors, these four linear factors, because they have exponents of 1 on the factor, and we are done. Okay, so that is the review for distributing and factoring.